Hi everybody, this is Algebra 2, Lesson 43, and this lesson covers trig functions of sine, cosine, and tangent, and we're also going to cover inverse functions. So before we get started on the new concepts, we need to learn some vocabulary. So we already know that when we have a right angle triangle, so a right triangle, that the side that is opposite the square corner here, opposite the right angle, is called the hypotenuse. So we already know that that is the hypotenuse. Now, if we are looking at one angle, so we have a 30-degree angle right here, the one that is opposite that is called the opposite. Pretty easy. And then the other one would be called the adjacent. It's adjacent to this 30-degree angle. Okay? And that is all relative to the angle that we're looking at. So if we look at this one, we've got our 90-degree angle. So the one opposite that is going to be our hypotenuse. So our hypotenuse is this side. Now, if the angle that we're looking at is this one, the one opposite from it would be down here. And then the one adjacent would be over here. So the angle that is opposite depends on which angle we're looking at. So let's say that we were looking at this angle, trying to find this angle, the one opposite that angle would be over here, and then our adjacent would be down here. Okay, so it's all relative to which angle we're talking about. And it doesn't matter which way our triangle is orientated, so I'll do one more. Here's our 90. Across from that's going to be our hypotenuse. And then if we're talking about this angle, our opposite would be over here. And our adjacent would be down here. Okay? All right, so they give us, in the textbook, they give us 3 triangles. And these 3 triangles are all right angle triangles, and they'll have a 30-degree angle over here. So our opposite is 2, and our adjacent would be, no, our hypotenuse would be 4. Now, if we set these up in a ratio of one side to the other side, we're going to do our opposite over our hypotenuse. So the opposite is 2, and the hypotenuse on this one is 4. For this one, the opposite is 60, and the hypotenuse is 120. And for this one, our opposite is 120 with a hypotenuse of 240. Now, if we calculate this out, 2 divided by 4, we're going to get 0.5. If we said 60 divided by 120, we would also get 0.5. And if we said 120 divided by 240, we're going to get 0.5. And this relationship is called the sine of 30 degrees. No matter what size this 4 is, it's always going to be 0.5. This 2 is always going to be 0.5 of this 4. So the opposite is always 0.5 of the hypotenuse if it's a 30-degree angle. Okay? All right. And that is called sine. So for sine, we have the opposite over the hypotenuse. For cosine, it's when we have the adjacent over the hypotenuse. And for a tangent, it's opposite over adjacent. And to remember this, you can use a little mnemonic device called SOHCAHTOA. So is S-O-H, Ka, C-A-H, and then TOA, T-O-A. So SA means sine equals opposite over hypotenuse. Ka would be cosine equals adjacent over hypotenuse. And then TOA is tangent equals opposite over adjacent. And you just have to memorize those. If you can just remember that remember that little mnemonic device, SOHCAHTOA, then you can remember what order those go in. All right, so if we were to draw this one out, the sine, that would mean that we would be talking about, here's our triangle, here's our right angle, the sine of angle A, so here's angle A. The sine would be the opposite, whoops, this one's opposite, over the hypotenuse. Okay, opposite over hypotenuse. For cosine, here's our triangle. We've got our angle A would be our adjacent, which would be down here, over hypotenuse right there. And then the last one, the tangent, would be the opposite. Here's our angle, so our opposite's here, over adjacent. Okay? All right. So 43.1 says find the sine of A, the cosine of B, and the tangent of C. Round answers to 2 decimal places. All right, so we need to find the sine of A. So here's angle A. Here's our angle right there. And if we remember SOHCAHTOA, and then CA-TOA, I usually write these every time I use them. So it's going to be sine equals opposite over hypotenuse. Here's our angle. So the opposite of our angle is going to be up here. So there's our opposite. This one's our hypotenuse. And our adjacent would be here. We need the opposite over the hypotenuse. So opposite is 4. So the sine of A equals 4 over the hypotenuse, which is 7. So to figure this out, I'm going to go to my calculator and I'm going to say 4 divided by, where's divided by? There it is, 7. And that is 57.5714, so we're just going to round to 0.57. Okay, so there's that one. This next one, we're supposed to find the cosine, and that's our CA, so that would be C equals CAH. So we've got adjacent over hypotenuse. All right, so the cosine of B equals adjacent over hypotenuse. So here's B, and our hypotenuse is here because it is across from our right angle. Our opposite would be this one, and our adjacent would be down at the bottom. Okay, so the cosine of B is going to be the adjacent over the hypotenuse. Well, our adjacent is 7, and our hypotenuse is 8.6. So if we go to our calculator, we do 7 divided by 8.6. We'll get 0.81. All right, and then the last one we have to find the tangent. Okay, so first we'll label our sides. This one's the hypotenuse. Here is our angle C, so the opposite of that would be over here. And the adjacent would be down here. Okay, and TOA is tangent equals opposite over adjacent. So if we're finding the tan of C, it's going to be equal to the opposite, which is 6, over the adjacent, which was 8. And we just calculate that out. 6 divided by 8, and we get 0.75. So those are pretty easy so far. 43.2 is talking about the opposite of that. That is called the inverse. So inverse functions. The inverse function, the inverse of sine, would be if we went backwards. So if we know that the sine of 30 degrees, sine of 30 degrees is 0.5, the inverse sine of 0.5 is 30 degrees. We're just going backwards, okay? All right, so this one says, find the angle whose sine is 0.643, and the angle whose sine is blah, blah, blah. So if we got turn on the pen, 0.643, and we need to find the inverse sine of that. We're going to go to our scientific calculator. Now, there's two different ways this is going to look on a calculator. So we're going to put 0.643, and here's sine, but we need the inverse of that. So I'm going to hit second, and on this calculator it says a sine, and that's equal to about 40 degrees. So we're going to say that's 40 degrees. Now, it may look different. It may look like on this calculator, 0.643. Here's sine, but we need to hit second there, and it says sine -1, and it's 40 degrees. Okay, so your calculator might say sine -1, or it might look like this one where it says a sine. That just means the inverse. Or you may have a calculator where you have an inverse button. So first you would hit inverse, and then you would hit sine. All right, this one we need to find the angle whose cosine is 0.216. So I'm going to say 0.216, and we need to find the angle whose cosine is that. So the inverse of the cosine, 0.216, and then we're going to say a cosine equals, and we get 77.53 if we round that up. So that'd be 77.53 degrees. If we did it on this calculator, same thing, 0.216, and we need the inverse of the cosine right there. We get the same thing. Okay, pause the video and do the practice problems, and then I'll come back and work on them. Okay, hopefully you guys pause the video for the practice problems. A and B say use a calculator to evaluate. All right, so this says 4 cosine 75.8. Now, when I did this on my regular handheld scientific calculator, I can just type in 4 cosine 75.8. But if I do that on this calculator, 4 cosine 75.8, I don't think I'm getting, it's making the 4 be the degrees, and we need the 75.8 to be the degrees. So what I'm going to do is I'm going to put in my 75.8 and hit cosine, and then multiply that times 4. So 75.8 cosine times 4, and we get 0.98, and that's the correct answer. So this one is 0.98. So I'm going to do the same thing on here. I'm going to do the sine of 37.42. 37.42 sine, and then I'm going to multiply that times 6, and I get 3.65. if I round it up. So 3.65, and that's the correct answer for those two. So be careful if you have an algebra calculator, it will do those algebraic functions for you. But if you don't, then you have to do the cosine first. All right, for these triangles, find the sine of C, the cosine of D, and the tangent of E. So for this one, we're going to find the sine of C. All right, so we've got C. It's right there. And let's label these. Let's see, there's our angle C. Our hypotenuse is this one. Our opposite would be this one. And our adjacent would be down here. Okay, and we have SOHCAHTOA, so that means sine equals the opposite over the hypotenuse. All right, so the sine of C equals the opposite, which is 3.61 over the hypotenuse, which is 7.52. And I just have to calculate those on my calculator. 3.61 divided by 7.52, and I'm going to get 0.48 as the answer. So let's answer that one, is 0.48. All right, the next one, we are supposed to find the cosine of D. Here's D. First, we'll label these. So D is our angle. The one that is across from the right angle is our hypotenuse. Then the one opposite D is our opposite. And the one next to D is our adjacent. And we need the cosine, so that's our CAH. C-A-H. So that means cosine equals adjacent over hypotenuse. So the cosine of D equals our adjacent, which is 3.63, over our hypotenuse, which is 4.76. So I just have to calculate that. 3.63 divided by 4.76. 3.63 divided by 4.76. And I get 0.76. And that's the correct answer for that one. So this one equals 0.76. All right, and one more of these. Oops. So this one we're supposed to find the tangent. So first we'll label. Here's our angle E. Our hypotenuse is right here. Our opposite is here. Our adjacent's down here. Tangent is TOA. So that means tangent equals opposite over adjacent. So the tangent of E equals the opposite, which is 8.73, divided by the adjacent, which is 11.30. So 8.73 divided by 11.3, 8.73 divided by 11.30 equals, and we get 0.77, and that's the correct answer for that one. Okay, and we just have a couple more examples. This next section here. Find the angle whose tangent is 0.405. Alright, so the tangent is 0.405. That means we need the inverse tangent. Of 0.405. So on our calculator, we're going to put 0.405, and then we're going to hit our second button and hit ATAN, and we get 22.05 when we round it up. So that one is 22.05. Okay, and I think there's one more down here. There it is. Find the angle whose sine is 0.794. All right, so that means that we need the inverse sine of 0.794. So we're going to go over to our calculator, clear that out. 0.794, was that what it was? Yes. Okay, and we need the inverse of the sine. So here's sine. When we hit second, there's a sine equals. And it's 52.56. So that would be 52.56 is the answer to that one. All right, I hope that made sense to everybody. But that is how you do sine, cosine, and tangent, and inverse functions. All right, thanks.